Hello and good day, everyone. This lecture that I'm going to be video recording for you in the next several minutes is for Monday, March 23rd. It is the first lecture after the extended spring break, and it is going to be about the introduction to music without a tonal center, that is atonal music. Several classes ago, as we began studying 20th century music, it was mentioned that the ultrachromatic music of especially composers such as Wagner and Mahler and Strauss in the late 19th century pushed tonality to its limits. And we had talked about in that prior class that the reaction to ultrachromaticism in music and the erosion of the traditional tonal system took two main paths. One of those paths was to steer clear of chromatic excess, retain tonal centers in music, but expand and experiment with various aspects of tonality. And in this process, or down this path, functional harmony and functional progression basically were abandoned. And that path can be seen over on the left side of the screen here. Anti-chromatic excess. Composers that were influencing this type of music at this time were Claude Debussy, Bela Bartok, and Igor Stravinsky. The other path, however, embraced and expanded chromatic saturation to the point of emancipating music from the principles of tonality completely. And this created music that had no focal pitch, or in other words, no tonal center. And so over here on the right of the screen we have the extension of ultrachromaticism, those composers that did embrace the chromatic excess in music, and they took it to the extreme to such a degree that music ceased to have a tonal center or a focus point, that is one pitch that is greater or more gravitational than any of the other pitches. And when music has no tonal center, we say that that music is atonal. That is the term that we use. And some composers that were fond of this technique in the 20th century were Arnold Schoenberg, Alban Berg, Anton Webern, and to a lesser extent Luigi Dalla Piccola. So today we're going to begin our study of atonal music. That is, music that does not have a tonal center to it. In short, we could say this is music that does not have a tonic pitch to it. As early as the first decade in the 20th century, some composers were creating music that did not have a tonal center. And this type of music actually resists, to this day, it resists any application of traditional harmonic analysis. So we can't take a piece of atonal music and we can't sit down and we can't start analyzing chords with Roman numerals. We can't necessarily analyze functional progressions, these types of things to figure out information about the music. It doesn't work well with atonal music. Because our traditional system of analysis doesn't work to examine and understand the underlying structure of this type of music, then what musicians did in the 20th century is they developed a systematic method to analyze music without a tonal center. And this systematic method is known as atonal theory. And another name for atonal theory, which means the same thing, is called set theory. And the term set theory will hopefully become more familiar to you, and you will understand why they call it set theory several lectures from now. As I said before, one of the chief proponents of atonal music was a composer named Arnold Schoenberg. And he lived approximately from 1874 to 1951, I would say. And one of Schoenberg's first atonal compositions was a set of 3 piano pieces that was published in 1909. And this was a set that he dubbed or called Opus 11. A passage of this piece by Schoenberg, in fact, the first of the 3 piano pieces, is excerpted in your textbook. It's found on page 505, and it is example 27-1. What we will do is we will go ahead and listen to this piece first. And normally, if you were here, I would ask your immediate or gut reaction after hearing this piece. Again, this is a piece with no tonal center, but wherever you are, just go ahead and come up with your mind what you think of the sound of this type of music on your own.
Example 27-1. After hearing this passage, you might be thinking, well, how on earth do I go ahead and start analyzing music that sounds and looks like this? And that would be a very good question. And over the next several classes, we are going to learn and understand a little bit about how set theory or atonal theory works. That is, strategies used to analyze this type of music, so we can at least understand a little bit about what the composer is putting in the music and what is going on in the music. The first step in analyzing a piece of atonal music such as this is to group the notes into collections of pitches called pitch class sets.
so that the notes can actually be compared to one another. Okay? So we want to be able to compare groups or collections of notes within this atonal piece with one another, and in order to do that we're going to start grouping the notes into small collections called pitch class sets. The process of segmenting the notes into pitch class sets, or grouping the notes into pitch class sets, is called segmentation. So first of all, we have this term called segmentation. Once again, it is the process of grouping small collections of notes from an atonal piece or an atonal composition into meaningful collections, which we will call pitch class sets. And I'll define pitch class and pitch class sets in a minute. Let me say a little bit more about segmentation first. Usually, pitches that are grouped together in the segmentation process are grouped together or chosen because of, number one, their close proximity to each other in the music, or number two, the pitches are related perhaps rhythmically or registrally, or they are part of the same phrase. So there are reasons behind why we group certain pitches together and analyze those groups distinctly, as opposed to, you know, just picking a note that's from here and then grouping it with a note way over here, or picking a note here and grouping it with a note that's way down here. Generally, the pitches are relatively close together, or else they have the same rhythm, or they're similar. They're in a similar register, either very high or very low, or basically they could be just part of the same phrase. We generally group pitches in atonal music into groups of 3 to 4, even though there is really a limit of grouping pitches into sets of 12. But we will generally be working with grouping pitches into groups of 3 and 4 pitches at a time. Let's talk about what a pitch class is. A pitch class is a pitch in the chromatic scale regardless of the octave in which it appears and regardless of how the note is spelled, which enharmonic spelling of that note is used, for example, to represent it. So I can give you an example of one pitch class, and let's start with and all the pitch classes are the same difficulty level, but one pitch class we could look at is the pitch class C. And rather than the individual term pitch referring to this C, or C4, middle C, pitch class includes all of the C's on the keyboard. So this C belongs to the pitch class C. And this C here belongs to the pitch class C. And if I were to change the clef, this C belongs to the pitch class C, and so does this one. Any C belongs to one and the same pitch class, and that pitch class for now we'll regard and term as the C pitch class. But also any enharmonic spellings of the sound C will also belong to the C pitch class. So, for example, I could respell C enharmonically as a B sharp. And since that sounds identical to C, it does belong to the pitch class C. And the same would be true for D double flat. which is another enharmonic spelling of C. It sounds exactly like a C, so it belongs to its pitch class. And again, any octave register, it does not matter. So I could use this D double flat up here, or I could use, for instance, a B sharp that's up here on the staff, or just anywhere on the staff. As long as the note sounds like some sort of C, regardless of its octave, it belongs to one and the same pitch class. So that, or B sharp, for instance, or D double flat. Now, that is one pitch class, and there are a total in atonal music of 12 pitch classes, because there are 12 distinct or different chromatic notes on the piano or on the keyboard. So we have the pitch class C, and any enharmonic spellings of C, like B sharp and D double flat. We have the pitch class C sharp, which includes C sharp and D flat and B double sharp, any note that you can think of that sounds just like a C sharp. We have the pitch class D, for instance, which would also be notes that are spelled as E double flat or as C double sharp, and so on and so forth. So we have pitches for all of the chromatic notes in the scale, and there are a grand total of 12. Just to illustrate a few others, for instance, here we have a pitch class G sharp. What other kind of notes belong to G sharp's pitch class? Well, this G sharp here, this G sharp here would, but so would also A flats in any octave. And so also, well, let's see, is there any other way that we could spell this? Well, no, I think really G sharp and A flat in any octave, I don't want to get into more than double flats or more than triple sharps or anything like that. So we'll just say that these notes all on the screen here belong to one and the same pitch class, and that is G sharp. Alright, so now that we've talked about what a pitch class is, let's talk about what a pitch class set is. A pitch class set is simply a collection of pitch classes. Just a group or a collection of pitch classes. And pitch class sets are notated using parentheses and commas to divide or separate the individual pitch classes in the set. And let me start by listing some pitch classes in a pitch class set, just randomly, and I'm going to list the pitches in the set of the pitch classes as letter names of the pitches. So for instance, we could, find have a pitch class that would go B, and it would contain the pitch class G sharp, and it would contain the pitch class G natural. And what we do in order to notate or write the pitch class set is we put the notes in any order, doesn't matter the order for now, and we enclose those notes in parentheses and we separate those notes by commas. Alright, now it is important to note and to understand that the pitch class set does not ever include pitch doublings, and a pitch class set such as this is by default unordered. In other words, it does not matter what order you write the pitch classes within the pitch class. For instance, I could have G and G sharp and B, and that would still contain the same pitch classes of the pitch class set. Okay, it would have the same contents. Or I could rewrite the pitches in the pitch class set as G sharp and B and G, etc., etc. Okay, so when we segment notes in an atonal piece of music, we choose maybe 3 or 4. What we're going to do is we're going to put them in a collection called a pitch class set. And you can list them in any order for now, enclose those notes in parentheses and separate them by commas. And that set or collection is by default, or it is inherently said to be unordered. We're not worried about any order of the pitches or the pitch classes in that set yet. Okay. Now, I must say that musicians have assigned the 12 pitch classes that are in music to a fixed series of numbers. So, whereas I'm listing the pitch classes by pitch letter names right here, what we're going to find out is that customarily in 20th century music analysis, composers actually assigned these pitch class letter names to a set of numbers, integers that is. And from now on, we are going to be listing our pitch classes within our pitch class sets as integers or numbers rather than as pitch letter names. I don't know how visible this is to you, but on the bottom of page 506 in the text is a brief green illustration, green table here, that lists all of the possible pitch classes and actually assigns an integer or a number to each one of them. Okay. So I said before that there are a total of 12 pitch classes in music, and what we're going to do is we're always going to label the pitch class C, or any note that belongs to its pitch class, such as B sharp or D double flat. We'll label that pitch class with a 0. Okay. Then you can see we have pitch classes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So we're going to start with 0 and we're going to end with 11, and that's going to include all the 12 pitch classes in music. Now, where do these numbers, were they arbitrarily chosen for the pitch classes? Not exactly. Perhaps you can see that, for instance, pitch class 1 is C sharp or D flat, pitch class 2 is D, and so on and so forth. In other words, what these integers represent is they represent the number of half steps the pitch class, each pitch class is above C, which is the base point or starting point of 0. So for instance, F sharp is pitch class number 6, because F sharps and G flats are always 6 half steps above C. And A sharp and B flat, those notes in that pitch class will always be labeled as pitch class 10, because these pitches are 10 half steps above C. By the way, this integer notation is called fixed integer notation. In other words, the pitch E or F flat will always be, for now, it will always be pitch class number 4. G will always be pitch class 7, and so on and so forth. It's based on the system where C equals 0. Now, on page 507 in your text, there is another table that the author uses, and I believe is a pretty nice illustration. On the left, we have some pitch class sets, 1, 2, 3, 4 of them, and all of the members of the pitch class sets, or all of the pitch classes themselves, are listed and notated as letter names. You can see B, G sharp, G. And in this pitch class set, we have G flat, F, and B. In this one, B flat, A, D flat, and in this one, D flat, E, F. Now the question becomes, what would these pitch class sets look like notated with the fixed integer notation system? That is, how can I turn all of these pitch classes listed on the left here into integers on the right? Well, just go back to the table on the bottom of page 506 in your text, and you can do the conversion. So for instance, B is always pitch class 11, G sharp is 8, and G is 7. And so we get the pitch class set 11, 8, 7. The next one, G flat, is pitch class 6, F natural is pitch class 5, and B is again pitch class 11. So we get the pitch class set 6, 5, 11. Again, it doesn't matter if the numbers go, are not in ascending order or descending order. The order does not matter at this point. Okay. In this pitch class set, we have B flat, which translates to 10, A, which translates to the integer 9, and D flat, which is pitch class 1. And finally, we have D flat, which is again pitch class 1, E, which translates to integer 4, and F, which is equal to 5. Now at this point, if you all were together and actually here, I would probably pause and ask for some questions. You are certainly welcome to, and I'm sure you will if you need to, back up this lecture, this recording, and listen to any parts that you need to over again, so that the information that I'm trying to disseminate to you sinks in. Just one other thing that I can think of off the top of my head. Rather than, sometimes instead of writing out the entire phrase pitch class sets, the author in your textbook will abbreviate this term and actually call it a PC set. Okay. PC standing for pitch class, not politically correct or something else. Okay. So pitch class is abbreviated to PC very often in the text. Now, between now and the next lecture, I do not plan to have, and I'm not going to have, a written assignment for you guys. The written assignment, first written assignment in atonal theory is going to come after I give you one more lecture. We still don't know enough of the information to really start working on a full-fledged assignment. So, the assignment for between now and the next lecture is going to be to read a few pages out of your textbook. I do hope you have your textbook handy, because I'm going to rely on it heavily in addition to these lectures. And I do want you to read pages 505 to 507. And I also want you to feel free to send me emails if you have any questions about something, or if you're having technical difficulties and for some reason cannot view this lecture. Whatever your concerns may be, I will try to field any and all email questions that I get. So I know it's a little brief without having to go through homework and things like that for this course lecture, but this is all the information that I wanted to get to you in one sitting. So I will see if I can get some more information about how I'm going to deal with returning graded homework, if that's at all possible, throughout this rest of the semester. I'm going to talk with some of my colleagues to get some different ideas, and I'll try to keep you updated and let you know about that, either through a lecture or on Canvas through an announcement.